Guys, and this is Coding with Gautam, and today we will be doing part 5 of IRP Emotion AI. So without any further ado, let's dive in. So today we are going to be covering feature and label separation, reshaping the data again, train test validation split, image pre-processing, normalization, and data augmentation. So let's take this all one by one. So first we have this code. This code, it basically separates the data frame into features X and labels Y. X is assigned the pixels column, which contains pre-processed image data, and Y is assigned the result of applying toCategorical from the Keras utils library. This function converts emotion labels, likely numerical values, into one hot encoded format. One hot encoding represents each emotion as a vector, with 1 in the position corresponding to the emotion class and zeros elsewhere. So this helps as it specifically singles out the emotion. Then we just look at how the pixels look. Then Y, we can see the ones are the emotions. And then we reshape the data. X is a list of image arrays because it was obtained using apply. NP stack X axis 0 stacks the image on top of each other along the 0 axis, creating a 3D array, a three-dimensional array. So it has length, it has height, and it has width. So this array is then reshaped to 24,568, 96, 96, and 1. This represents 24,568 samples, the number of rows in the data frame, 96 by 96 the image size, and 1 the grayscale. And then you print the shapes to help confirm the data structure. Then you do the test train split. So this code splits the data into training, validation, and testing sets using the test train split from sklearn. The first split creates a test set of 10%, 0.1. of the data. The remaining 90% is used for further splitting. So you train the model on 50% of the data. Then you validate it. You just validate the model for its accuracy on the other 50%, and then you use the 10% to test it. Then we have the shuffle. Shuffle ensures that the data is shuffled before splitting to promote better model generalization. And the result, training, validation, and test sets are stored in separate variables: xtrain, xval, xtest, ytrain, yval, and ytest. So the print statement displays the shape of each set, allowing you to verify the split portions. We have 1,228, 1,228. The test is 1,229, the 1,229, and then you train it on 22,000. So you train it on 90%, then you validate it using 5%, and then you test it using the other half. So then the pre-processing. So image pre-processing, first you normalize the data. The first lines. So basically here you just pre-process the image, you just divide everything by 225. So now you can have separate pieces of data. And next, then this normalizes by the pixel value in each image dividing by 255, which assumes 0, which is because grayscale is 0 to 255. Then we augment, then we just display to see how it looks. Then we augment the data as this code defines an image data generator, which uses the Keras pre-processing images. This is used for data augmentation, which creates new images from existing ones. So we can see that it rotates from 15, the width and height shift, the shear range, the zoom range, horizontal flipped, and the fill mode is nearest. The specified parameters introduce the random variations. So yeah, then this is today. Today we were just making sure that we split the data, normalize it, and then we get the data ready for tomorrow, where we get the res block, incorporate Atom, make sure we actually test the training, validation, and security, do some more data augmentation, understand how the model works and how accurate it is, what are the problems, and then we test it. So thank you guys for watching. Don't forget to share, like, and subscribe. continue on with the series. This is Coding with Gautam. Have a good day.